All right, nice. So everything in order. So what I mean, I could use this diagram to kind of give you an idea of what differentiation is about, right? If you look at this right angle triangle, you'll recognize that there's a little slope, right? This slope, how can I alter this slope? Anybody could tell me? Well, what's the diagram? How can I alter that slope? How can I make it more slopey or less slopey? What I can do? Change it. Okay, change the height. So I can make it higher and change the slope. Could I change the length as well? Yeah, and I'll change the slope. Right. So what this slope really represents, the slope represents how the change in y and the change in x, how they affect how this angle is here. Right? So the slope represents, if you remember the formula for slope of gradient, it is the change in y over the change in x. Right? So the slope is change in y with respect to x. Right? And that is exactly what differentiation is. Right? So if we have some function f of x is equal to y, then its differential, right? Its differential is the change in y with respect to x, right? This represents change in y with respect to x. All right. So again, what you also recognize is that differentiation is the same as slope. You're saying that? All right. I can leave the same diagram here. Right. So differentiation is if we have a function, its differential is how y is going to change when you change x. Okay. So you can kind of make a guess here on what we're doing. All right, so we're going to look at how to differentiate now, right? How do we obtain dy dx? Jeremy, you can get us a question number. How is getting dy dx? Okay, so how do we differentiate? Really easy. In order for us to differentiate, we have a few steps to take, right? We take the power and we bring the power down. So you bring down the n, then you multiply it by a and you minus 1 from the power. So the differential of ax to the power of n is nax to the n minus. Right? Now looking kind of hard, so let's do an example. If I give you y is 3x to the power of 4, watch how easy it is, right? dy dx, or by the way, sometimes instead of seeing dy dx, you will see y prime. They both mean the same thing. Okay? So watch this here. You bring down the 4. Right? That's step number 1. Then you write back the a, which is 3 in this case. And then you minus 1 from the power. All right. So you'll end up with 12x cubed. Okay with that? So that's the way you differentiate. Multiply minus. Okay? Multiply by the power minus 1 by the power. Okay with that? Write it down. Multiply by the power, second step, minus 1 from the power. So you multiply minus. Copy it down. Any questions online? Well, watch it again. I bring down the power. Bring down the power. I write back the 3 and a minus 1 by the power. So I end up with 12x. Copy down. Try number 2. Online, don't get a message, right? Online message answers. Let's see what you get. What you get you. What you get me? 14. You sure? 14x. That can work very good. Good job, Crystalline, Venetia, Asia. Nice. Hamlet. Okay, nice. That good start, right? 2 by 7 and minus 1 from the power. And minus 1 from the power. So that's 14x. Okay, 14x. Very good. Let's go again. I'm gonna give you a 2 to cross up here there with. This one easy, right? Y is equal to 3x. Number 4, y is the square root of x. Find the differentials. Come on. Find the differential of each one. Yeah, boy. Okay, let's do that. Huh? The differential. So the same thing you did here, you do it. Y prime and dy dx, same thing. So I am asking to the differential. Right? The differential means dy dx. So differentiate this, just like what you do here. Differentiate just like what you do here. Everything you do here. This one is understood to the power of. Right, differentiate that there. All right, so let's check out the first one. What we have here. So you're bringing down the 1, writing back the 3, and you're minusing 1 from the power. So that's 3x to the power 0. And anything to the power 0 is 1. So the answer is 3. Right? So in short, if you have to differentiate 3x, just remove the x. Okay? How about here? Jeremy, what do you do here? Square root of x means what? X to the power of a half. Right? Then you bring down the half. You bring down the half. There's a 1 understood here. And then you minus 1 from the half. So you'll get a half x to the minus a half. That's okay? But you can't leave it like that. Yeah, you gotta put it back like this. So what does minus a half mean? 1 over. Right? Then you multiply it here, right? So you'll get 1 over 2 root x. 1 on 2 root x. Any questions online? Later. Yeah. How we differentiate enough? Severe, what do you think? Any x? Any x? So here we could do, right? You know what's the answer? 0, right? You can just compare exams, right? Here's what understood. We know that this is like 3 by 1, right? So we could also say this, right? X to the power 0 is 1. And then what you'll do? You'll bring down the 0, write back the 3 and minus 1 from the power. But 0 by anything is what? 0. Which one? Yeah, it's 0. Yes, I can see that, but I want to show you where it comes from. Right? But yes, the differential of any constant is 0. Right? But I like to show you where it comes from. Okay? Online, are you okay with that? Are you okay with that online? Rihanna, Emirates? Right? So put it all together now. Differentiate this, then differentiate this, then differentiate this. Let's see what you get. Same thing, let's do it piece by piece. Online, are you okay there? 3x squared minus 4x plus 2. Elizabeth, are you okay there? Crystalline, good job. Narayan, good job. Finish. So you can do this mentally now. The differential of 3x squared, bring down the 2. 2 by 3 is 6. That's a 6, huh? And then minus 1 from the power, that'll give you 1, right? The differential of minus 4x, chop off the x. Differential of 2 is 0. So that's the answer. Yeah? Are you okay with that? No, Jeremy? Small thing. Come on the board and do this one here. Now, I want to make sure you're good. No. You know, I'm a 7 there for now. Come on the board and do this one. 6x cubed minus 4x squared plus 2. Finish it. Sorry there. Right? What you all got? So 3 by 6 is 18. Minus 1 time power. Here's what? 2 by 4 is 8. Minus 1 time power. And the differential of 3 is 2. Very good. Right? So that's the principle of differentiation. Are you okay with that? I would handle something like this. Maybe here. Suppose that online or in messaging now. Okay, now I guess so much. Mikhail, how you would differentiate something like this? What number is this? Mikhail, suppose I gave you something like this. 2x minus 1 to the power 2. How you would differentiate that? Forget the rules. Forget the rules. Based on what you know from today. Expand it. Expand out that bracket and then differentiate. Okay. Right? So expand it out, then differentiate. Do that, please. I mean, I know it's so long. Right? Let's see how you expand it. 2x squared, 4x squared, minus 1 squared plus 1, and then you multiply minus 1 by 2x, which is minus, right? Remember that shortcut? This squared, and then 2 by this, Minus 1 by 2x is 2x, multiply by 2 is that. Right? Then the differential of 4x squared, 8x, the differential of minus 4x, minus. Okay? Everybody get up? Online? You all got up? So it's 2x minus 1 by 2x minus 1, right? This squared, then you multiply this by this and multiply it by 0, and you get out. Then differentiate. Was it how we differentiate in this later? Suppose I give you 5 over x cubed. How we differentiate in that? Bring up the x. What you'll get? Nice. And now you can differentiate that. dy dx is equal to minus 15 x to the minus 2. Sorry. Minus 4. Okay? Or you could write it like this. Minus 15 over x to the 4. Okay, that? Everybody okay with this? So we are. I thought upside down was starting today. Try this, please. You have to simplify it first, right? Right? You have to simplify it first. Divide it first. Divide each term individually and then do that. Writing it on, yeah, you find it easy. Go ahead. Yeah, them individually, right? Do them individually. Differentiate. Divide this, divide this, divide this. Work it out individually and then differentiate. As soon as the first one, I'll give you a little help, right? But you have to finish it off. Simplify this. Simplify this. Simplify this. Yeah. I have calculate. Right, let's go simplify. So it's simplified to same base, 2, 3, you're gonna minus. So that is 2 minus 3 is minus 1. Here, 5 minus 3, that's 2. Here, the cube will cancel, so you'll get 2. That's okay? Same base and you divide it, right? So when you divide, you subtract 2 minus 3 is this. That's okay? Yeah. So now we differentiated dy dx. Bring down the power, minus 1 by 3 is minus 3. Minus 1 is minus 2. Here, 2 by 4 is 8. Minus 1 from the power. And the differential of this is 0. So, final answer, minus 3 over x squared minus 8x. You're in the habit of putting it back like this, right? That's okay? Stop very much. Sure. All right, you're coming to go on to the last one. Yeah. Number 11. Let me change it up a little bit. I don't have to do. I'll do something with that square thing. I'm gonna get this done. Or look at handle it, man. Or look at handle. 3x squared minus 2x over root. Huh? That's not one of the. Yeah, one the index rule simplify. You're doing it by quotient rule, yeah. But you're not doing that. But you remember that. But no, we're not doing that. No quotient rule, eh? You're doing it just like number 10. And please try to write back your answer with a square root, right? Take your time, huh? This one should be to simplify out. Square root means to the power of a half, right? And let's see how this one, and then we'll go back to some easy ones, right? Let's see how this one, and then we'll go back to some easy time. Right, this one here, the hard part was to simplify. So this is 3x squared over square root of x, which is x to the half. And this is 2x over square root of x, which is x to the half. Same base, you divide it, so you're gonna subtract, right? So that'll be 3x to the 2 minus a half is 3 on 2. Right? And 1 minus a half, 1 minus a half is a half. Right? So this here is your simplified equation that you're going to differentiate now. So dy dx is bring down the power, 3 on 2, write back the 3 and minus 1. If you minus 1 from 3 on 2, you'll get a half. Right? And then here, bring down the half, write back the 2, and minus 1 from a half, you'll get minus a half. So this will be 9 on 2 by x to the half. And here it will be a half by 2 is 1. So that'll be 1x to the minus a half. I gave you it with a root, write it back with a root. So you'll get 9 root x on 2 minus 1 on root x. You leave it like that, or you can find the LCM and make it look nice. Right? If you found the LCM, it might look like this. 9x minus. Everybody get this one? You get it like this? Which one? Smaller. I mean smaller. You minus these two. But you had this.
Yeah.
Yeah? You get this? Good. That's the most important part. But if anybody get it online, somebody had messaged something. 9.5 root x minus root x. Pull out x and you get 9 on 2. Now, make a little mistake, Elizabeth, but you was close to it. Jason got it. Just type it kind of bad, but that was good. Good job, Jason. Let's tricky to simplify. Narayan, if you follow what to do, Hamlet. Yeah. All right. So that was a little tricky to simplify, right? And as we said, there are rules that we can use later on to differentiate them using quotient rule. All right. So we're going to take a look at our first rule. The first rule that we're going to look at is called chain rule. All right, kind of chain rule. First one is chain rule. That's the first rule we're going to look at. Right, chain rule can be used to differentiate questions like that. Ready? So we're gonna try to use this rule here. dy dx is equal to dy du by du dx. Right? When we use this rule, we're going to have to introduce a new variable, u. Right? We're going to have to find a way to bring in that new variable u, right? So let's see if we can use in this example here and allow it to make some sense. Ready? There's a 4, right? So how do we use chain rule? Watch up here. Really easy. First thing we're gonna do is we need to find a way to introduce u. So let's say let u equal to this here. Let u equal to 2x minus 1. Right? So if I let u equal to this, then y will be equal to u to the power of 4. You see enough? So if I let u equal to this, y becomes u to the power of 4. Okay with that? Now I want to use this formula here. So I need to get dy du, I need to get du dx. Okay? So the differential of this will give me dy with respect to u. Right? The differential of u to the 4 is 4u cubed. That's okay? And the differential of this will give me du with respect to x. That's okay? So du dx comes from here and dy du comes from here. What's the differential of 2x minus 1? The differential of 2x is 2. Differential of minus 1 is 0. And that's it. We have du dx, we have dy du. So now, remember, our objective really is to find dy dx, right? dy dx is equal to, using the formula there, dy du multiplied by du dx. dy du, that's this. That's 4u cubed, and du dx is 2. So it's 2 by u is 8u to the power of. Okay, that? But we can't stop there because our answer should be in terms of x. So u is 2x minus 1. So this becomes this. So what's the power of 3 come from? The power of 3 is when I differentiate this, bring down the power and minus 1 to the power. So it becomes 4u to the 4 minus 1, which is this. Yeah. Are you okay with this? Okay. Come on. Copy it down and let's just try one now. Try that in. I'll pass it around. I want you to right? Take your time online. Y is equal to 2 minus x equal to the power. Take your time, follow all the steps. What you let u equal to? What you let u equal to? 2 minus x, right? So u is generally whatever in the bracket. Right? So let u equal to 2 minus x. Right? And then follow the steps. Okay? Hurry up. Let's see if we get that. Hurry up. Do all the steps. I'm going to finish. Check out this. Next is what we number two. Someone for the show. Okay. We differentiate in one of these. Yes. Alright, let's see what you got. So what's du dx here, Jeremy? Jeremy, what's in man? So what's the differential of 2 minus x? And what's the differential of u cubed? What's the differential of u cubed? The differential of y with respect to u. What's the differential of x cubed? I'm okay. So just differentiate this, bring down the power and what? Right, so it'll be 3u squared, right? So that'll be 3u squared multiplied by du dx. Du dx was minus 1. Minus 1 by 3, that'll be minus 3u squared. And u is 2 minus x squared. Huh? I'll take up here. Next one. Online, you all get up? Yeah, nice. Good job, Adrian. Let's see, y is equal to 5 by x minus 2 to the power 3. Try that fast. All the sets. Oh yeah, punctual. Finish. What's important? Right, so there's a shortcut for these, huh? Let me show you. Have a shortcut method to these as well. I'll probably show you on this one. But if a question says to use chain rule, well, you have to use it, right? So the answer right online, let me see somebody in some answers that we will see. Elizabeth, Narayan, Jason. Let me see. Renisha. Vinay, you two. Send some answers, please. Vinay and Renisha, send answers, please. Crystalline, check bucket powers, right? Did I make a mistake? One little mistake with power. Right? So what you let u equal to? You let u equal to what? X minus 2. So we can immediately find du dx. Du dx is 1. The differential of x minus 2 is 1. Y is equal to, we replace this with u. Y is 5 u cubed. So now dy du is equal to the differential of this 3 by 5, that's 15 u squared. That's okay. 15 u squared. And now we're using the formula. So dy dx is equal to dy du multiplied by du dx. Dy du, that's this. I don't really like the multiply sign so much, right? I use it dot. Dot du dx, which is 1. So that's 15 u squared or 15 u x minus 2. X minus 2 squared. Right? Christelina, so a little mistake here. Are you okay with that? Yeah? Right. This is the long method. If a question says use chain rule, you have to use this. But there's a shortcut as well. If they don't specify, you can use this shortcut. Right, the shortcut method already have our official name, we just follow the shortcut, right? Alright, so the shortcut method is this. The shortcut method is very similar to what you've been doing before. Number one, you bring down the power. So you bring down the power. Number two, you differentiate inside the bracket. Number three, after you differentiate inside the brackets, you write back the bracket. Well, determine the bracket, right? Write back determine the bracket. And step 4 minus 1 for the power. Right? So I'll use this as an example. Y is equal to 5x minus 2 cubed. What you say? Right? 4 easy steps, Nathan. 4 easy steps. Bring down the power. Bring down the power, which is 3. Differentiate inside the bracket. Differential of x minus 2 is 1. Of course, write back the 5 and write back the bracket. That's okay? Don't leave out the 5, huh? Right? Write back the 5 and write back the bracket. And then minus 1 from 3. So you'll be left with 15 x minus 2. Same thing. Right? But it's much shorter, right? Are you okay with that? Copy it down, 1 for the root. You could use any method you want. Any method you want for this last one. Which method you choose? Shortcut. You chain rule. Which one you choose? Yes. So you use the shortcut method. What does square root mean again? Oh, a half, right? Square root means to the power of a half. So help me to do this one, Rima. What's the first step? Use shortcut. What's the first step? We're using 2x minus 3 to the half. What's the first step? Bring down the, so the power is what? Half. What's the next step? Differentiate inside it. So you differentiate in here. Well, what's the differential of 2x minus 3? 2, nice. What's the third step? Right back the bracket. So the bracket is 2x minus 3. And the last step is what? Minus 1 from the half. A half by 2 is 1. 2x minus 3 to the minus. That's it. But don't leave it like that. Right? This is 1 over the square root of 2x minus. Right? Leave the answer in this one. If I give you a square root, give them back a square root. See how easy? All right, nice. So today we just did intro into differentiation and product. Chain rule. Right? Next we'll continue with the product multiplication and intro. All right. So that's it online.